building underground habitats where you got good radiation shielding. You could build really an entire city underground if you wanted to.
Hey, this is Warren Redlick. I wanted to talk to you today about how SpaceX and the Boring Company will build colonies on Mars and the Moon in a way that protects humans from radiation and from the effects of low gravity. Are you ready? Let's go. While there's a lot of other things to worry about with humans on Mars or the Moon, for example, making sure they have breathable air and making sure they're warm enough, we think we can solve those problems. That's pretty well understood. There's two critical things that we're concerned about for the long term. First is radiation. The concern is that if they're exposed to too much radiation on the Martian surface, we know that the amount of radiation hitting the Martian surface is very high and is not good for human health. It's worse than it is in low Earth orbit for astronauts because the Earth's atmosphere and magnetic field still protects humans who are in low Earth orbit. But you get them out to the Martian surface and there's really not much to protect them from cosmic radiation and the sun. One of the key things we can do to protect people from radiation is to go underground. Elon Musk has talked about it, many people have talked about that humans living on Mars or the Moon would probably spend a large percentage of their time underground.
Getting good at digging tunnels could be really helpful for Mars. For sure, there's going to need to be a lot of ice mining on Mars and mining in general to get raw materials. Building underground habitats where you got good radiation shielding. You could build really an entire city underground if you wanted to. People are still going to want to go to the surface from time to time. You can build a tremendous amount underground.
They would still be able to spend some time on the Martian surface, but you'd want to be careful to limit time on the Martian surface to as much as necessary to minimize that radiation exposure. So the big question then is, how do you design life underground on the Moon or on Mars? And I think I've got the answer to that. So the second thing is living with low gravity. We've seen when astronauts are in low Earth orbit for extended periods of time that their bodies suffer. Our bodies adjust to not having gravity and they don't adjust in a good way. We don't know for sure how long-term exposure to low gravity will affect humans, but there's a good chance that it's going to be harmful to be in the 0.38 Gs of gravity on Mars, which is 38% of Earth's gravity, or the 0.16 G gravity on the Moon, which is 16% of Earth's gravity. We're pretty sure that that's a good chance that will pose substantial risks to the human condition. A lot of people have talked about the same issues in space travel, coming from Earth to go to Mars, from Earth to go out into the solar system. One of the common proposals that we see for astronauts traveling in space is some kind of rotating space station that creates centrifugal force. So your feet, you're on the outside of a circle, the circle's moving like this, your feet are on the outside of the circle. You can get in an argument about centrifugal versus centripetal, but the centrifugal force pushes down on you in the same way that gravity pushes down on you. There's concerns when the loop is too small that the gravity you feel at your feet is different than the gravity you feel at your head because your head is closer to the center of the circle in a significant way. We can apply that to the Martian colony and the Moon colony in this way. We can build loops using Boring Company tunnel boring machines to create big circles where we would put trains or train cars or something equivalent to that running around in circles and traveling at a high enough speed that it generates enough centrifugal force on the people inside that they feel the equivalent of Earth gravity. So the way I picture the Mars loop or Moon loop happening is you start with the existing tunnel boring machine technology that the Boring Company is using, where they have a 4-meter diameter tunnel boring machine. They bore tunnels that are a little bit less than actually 4 meters. You take that in a loop that has a 200-meter radius or 400-meter diameter. It works out to being about 1,250 meters around, or 1.25 kilometers, or 8 to 9/10 of a mile around. Your goal is to generate enough centrifugal force to compensate for the less gravity that you have on Mars. It works out that you need to generate about 0.9 Gs of gravity with the loop, plus the 0.38 Gs of gravity from Mars, and when you work out the math, that works out to about 1 G. To attain that 0.9 Gs, you need to go about 2 RPMs, 2 times around the circle per minute, and that works out to about 90 miles per hour speed. An interesting side note to this is it's a lot of volume that you're going to create. The tunnel volume works out to be about 15,000 cubic meters. It's a lot of space, which in the end you're going to use the material in a way I'll talk about at the end of this video. Initially, you're going to start with one car. That one car will be about 10 meters long. It'll be about 3.8 meters in diameter. And you'd create a floor on the car that under which you would use for storage, and above that you'd have your living space. It would work out to about 3,000 square feet in one car, which, given that we're talking about the early Mars colony or the early Moon colony, if the average person can get by with 100 square feet, which is like having a 10 by 10 room, then in total you're able to support 30 people in just one car. The way I picture it, and I think the way Elon pictures it, most people would spend most of their time in this car in motion. When it's at rest, the car would be at the bottom, would be resting on the bottom of your tunnel, straight up, and you'd have 0.3 AGs pushing down, which is light for us humans. As you get up to speed, the car is going to go up along the outside of the wall to nearly horizontal, but not quite. You'll have a total of 0.9 Gs pushing. It works out to 1 G pushing down on you at an angle. You still have your storage space underneath. It simply rides up along the wall. I don't think you need rails. I think you would use some kind of low resistance surface to the tunnel and low resistance tires or wheels running on the surface of the tunnel, and it just rides up as it speeds up, going from straight up to up on its side. I should mention that 90 miles an hour should not be very difficult to do. The atmosphere inside the tunnel, not inside the car would be pressurized, but inside the tunnel, the Mars atmosphere is very, very thin, so there's not a lot of air to push out of the way, so you have virtually zero wind resistance. And if you use low rolling resistance tires and use a smooth surface on the tunnel, you should be able to minimize that. And it's just a matter of getting up to speed, coasting, and then getting down to zero when time comes, using batteries that recharge, using regenerative braking when you slow down. So it should be a very low energy system to maintain and operate. One of the concerns that you see people talking about with this form of using rotation to generate artificial gravity is the Coriolis effect. My understanding is because we're at 2 RPMs, the Coriolis effect should be fairly minimal. Also, the difference between gravity, the feeling of artificial gravity from your feet to your head, there is a slight difference because we've got a 200-meter radius and the average person is 2 meters tall or less than 2 meters tall. So the gravity felt at the head versus the feet is close to within 1%. It shouldn't be that dramatic. It's still there. It could potentially be a problem, but it's minimal compared to a lot of other alternatives. As the size of the colony grows and the number of colonists grows, it's easy to just add cars to the loop. You start with one car, you add another car, you add a third car, you get to 5 cars, you get to 7 cars, and each car, if it supports 30 people, as you add more people, you just add more cars. These cars shouldn't be expensive to build or maintain. They can be fairly lightweight. They don't require a lot of material. They're not going to crash into anything, so they don't need the high level of structural rigidity that you might need in a situation where you're expecting crashes. So that should work well. And ultimately, if you have a 1,250 meter circumference loop and you're adding 10 meter cars, these are all ballpark numbers, there's a little bit of roughness here, you should end up with a capacity of up to 125 cars around the loop. And with 125 cars, that ends up being 375,000 square feet of floor space that people are able to live in with all the storage underneath. That doesn't include space we're going to include outside the loop. I think the expectation is that you would sleep on this car. So that's 8 hours a day, roughly, that you're sleeping. You would probably spend at least another 8 hours a day inside the car, and then you would go out either to Mars-level gravity spaces in underground or sometimes above ground onto the Mars surface. And the way I envision it, and I'm sure there's other ways of doing it, the train stops about every 8 hours. Every 8 hours it stops, and the people who are going to get off, and then people sleep in shifts. In theory, if you really push this, one car could sustain more people because you could squeeze more people in. You don't necessarily need 100 square feet each. And if you're rotating who's sleeping on shifts, then you can have 3 times as many people on that rotation. So theoretically you can support even more people. I don't know if it's necessary to support more people, but perhaps in the early days you'd want to do it that way until you've scaled up the colony and the colony has grown and you can afford to do more. I think it really starts to get interesting when you talk about the other spaces that you're going to create underground to go along with the loop. You would have some kind of underground work areas underground. When I first was thinking about this, I imagined these large rectangular or circular spaces. As I look back on that, I don't know that that makes sense. I think it's a lot easier to do it in tunnels. But one way of looking at it is here. I think it's hard to support the ceiling. If you dig a big cavern underneath, will the ground above cave in? I'm not sure how big of an underground workspace you can create in this way if you make them rectangular or big circles. So another idea is you just simply create more tunnels using the same boring machine that's creating the loops. And perhaps you eventually build larger tunnel boring machines that build tunnels that are more than 4 meters in diameter. Maybe they build tunnels that are 10 meters in diameter, which creates a lot more usable space. And at the same time, as long as you go 2 tunnel diameters down from the surface, it shouldn't create any disturbance on the surface or anything above it. And you can go arbitrarily deep, as Elon likes to say, and create you can do a lot more as long as you just go underground a little bit. I should mention another advantage of being underground, in addition to radiation, is every once in a while something hits the Martian surface. Some kind of small asteroid, meteorite, whatever, hits the Martian surface. If you're underground, 10 meters underground, that's unlikely to cause a problem. You're a lot safer from that type of impact if you're deep underground. So I think the tunnel idea makes a lot more sense, that you just create tunnels that go first inside the loop, that connect each side, and then when the train comes to a stop, remember you've got 125 cars, you get out of the car, you hop into one of these tunnels. The tunnels inside are pressurized. You'd probably need some kind of airlock system to get out of your pressurized car and get into the pressurized tunnel while going through the unpressurized loop. That's one issue. But using this scenario I've laid out, you would have a lot of these tunnels, and a lot of these tunnels would create a lot more workspace underground. I don't know how many you would need, but you would be able to make as many as you want to make. And you can expand it. Ultimately, when you get beyond the number of people that one loop can support, you start building more loops, and you create tunnels between those loops. And you end up with a growing network of loops. So if you keep expanding to more and more loops, as the Martian economy grows, as the Martian population grows, you start with one loop, you add a second loop, now you've got 2. You've gone from 3,500 people in one loop to 7,000 people in 2 loops. Ultimately, you can see expanding that to 8 loops. You can see that expanding to 72 loops. You can see it expanding to 4 groups of 72 loops. It's 288 loops. You work those numbers out, it works out to 1 million people. So it's a fairly straightforward process to get to the point where you have a network of these loops. I'm not saying how long. I think it takes a long time to get there in terms of getting the people from Earth to Mars, in terms of building loop systems. But it's a path that makes sense, that over the next 3 to 5 decades, we can see building out a Martian underground city of 1 million people. And I think one of the big questions that we'll face on Mars is, do we make the loops spread out horizontally so that you have 288 loops all at the same level, or do we stack them? Because one of the beautiful things about tunneling is you can go arbitrarily deep. So it may make more sense to take that one spread of 72 loops and then stack them, rather than having them spread out geographically horizontally over a wider area. Stacking them makes sense in a variety of ways. You keep in mind, if the tunnel diameter is 4 meters, you'd want to go down at least 8 meters from one loop to the next loop, and maybe you'd want to go down a little further to give yourself some cushion. You're really only going down less than 100 meters to get to the bottom of 4 stacked loops. It'd be significantly less than that. So there's a lot of room in there to create your network. And the big advantage of having them stacked is now you're all more centrally located, and your resources that are above ground or other resources that are centralized are easier to get to than if you're spread out horizontally over kilometers. There's no shortage of horizontal space on Mars, so if it's decided that that's the way to do it, it's certainly easy to spread out horizontally, and you're not going to run out of room on a planet. For just 1 million people to spread out in that way, you're going to be fine. I still think it's going to make sense to stack them, but that's a decision that will be made by people on Mars, and it's a long ways off, because first you got to build the first few loops, and I think the first few loops you would end up putting them next to each other. One of the byproducts of boring company tunnels is boring bricks. The boring company produces bricks as part of its process of boring out tunnels. It uses those bricks, it sells them cheap or gives them away for free to nonprofits. It's actually a problem for a lot of tunnel boring businesses is what do we do with all this stuff that we take out of the tunnel? And the boring companies figured out we can make bricks with it. Well, Martian colonists can use those bricks to build above ground structures, possibly use them below ground, and there will be a huge volume of these boring bricks that will be available to do whatever is going to be done on the surface of Mars. And if you stack the bricks enough, they may provide some radiation protection as well. That may be an additional technology thing that will come out of this process is how we can use these bricks to protect people on the surface from the harmful effects of radiation while they're in structures that are on the surface. So I know we're looking a long way down the road, but I personally am very excited about the prospects of developing a colony on Mars. I think a couple of thoughts when I talk to people about this, they're like, well, Joe Rogan, for example, says, who wants to go to Mars? You know, it doesn't take a large percentage of the population to want to go to be able to support 1 million people on Mars. The Earth's population now is around 7 or 8 billion. In 20 or 30 years, it might be 9 or 10 billion. If 1/10 of 1% of the population, in other words, 0.1% of people, 1 in 1,000 people, wants to go to Mars, that's 10 million people. And we're only trying to get 1 million. So really, if we only get 1 out of 10,000 people who are interested in going to Mars, it's enough to support a Martian colony. Another important thing that I've heard people talk about with Mars is, well, what's the point? What's the Martian economy going to be based on? What are they going to do? And you probably could have said the same thing about coming to North America when you're in 1492 or the 1500s. Very in-hospital environment, very difficult living circumstances, and what's the point? It was pretty apparent what the resource value was there. But I do think there's a tremendous value in having a Martian colony for this particular purpose, which is to further explore space. Elon has talked about this. The Earth is a very large gravity well. It's not so big that we can't get off, but it's so big that it's hard for us to launch substantial missions deeper into the solar system or outside the solar system. Because Mars has a so much smaller gravity well, it is much easier to launch larger missions to longer distances off of Mars than it is Earth. So we can view Mars as a staging ground. And the same thing with the moon, by the way. All the stuff I've talked about with the moon, with Mars, we can talk about with the moon. I personally see Mars as a little bit more advantageous for a bunch of reasons. I think it's more possible to turn Mars in the long run, to terraform Mars or make Mars habitable in a better way. I think the moon is a bigger fixer-upper than Mars. The moon is closer, so it's easier to get stuff there, and it's closer, so it's easier to communicate with the moon. But I think Mars ultimately has better prospects. But we can, as far as I'm concerned, let's do both. But you can use the small gravity well of Mars to be able to launch missions to Jupiter, to Saturn, to beyond. You would be able to launch larger and longer missions without the hardship of getting out of Earth's 1G gravity well. Coming off Mars is a much smaller gravity well. It's capable of doing a lot more with it. So I'm very excited about the prospects. I hope you're excited. I can't wait to see what SpaceX does next. Let's stay excited. Keep rooting for SpaceX and other. I'm rooting for Blue Origin too. Let's see them do O'Neill colonies. It's a wonderful future that we have to look forward to. Let's keep it going. Thanks for watching. And of course, please subscribe. Please check out my other videos. Have a good day.